Alright, so welcome everyone. Today we are happy to have two speakers for today's seminar. Our first speaker is Professor Tsing, also known as Jerry, who is a professor at the Department of WE, National Tsinghua University. Professor Li received his bachelor's degree and PhD degree both in WE from the Southern California University in 2007 and 2012, respectively. Professor Li spent 1 year in the industry as a data scientist before joining National Tsinghua University, and he has received numerous awards, including the prestigious Outstanding Research Award from the National Science and Technology Council of Taiwan, I think just this year. Today, Professor Li will share his recent work on speech technology and affective computing. Without further ado, let's welcome Professor Li for his talk. Professor Li, please go ahead.
All right, thank you. So, thank you for this seminar series. Today, I'm going to share basically maybe not recent work, but more of my view on a whole sort of field of speech technology with affective computing. So, speech technology and affective computing, from scientific exploration to recently, when we talk about responsible AI application and what are some of the things that has already happened and what are some of the things that's going to happen. Okay. Thanks for the introduction. Again, a bit of introduction myself. Come in Germany is fine. I'm mostly in WEs. Also have joint appointments in Academia Sinica at the Research Center for Information Technology and Innovation and various other departments at NTHU. So again, my research interests, if you listed here, they're affective computing, speech processing, health analytics, trustworthy AI, and behavioral analysis. If you see this interest, you kind of know, we're talking about a human-centered computing kind of thing. By collecting human data, we're able to compute, understand, and try to react according to, some human traits and states. All right, so before going into the talk, I'd like to share a little bit of videos that it was quite a while ago, but probably back in 2019, 2018, Discovery Channel did a sort of series on financial technology. A part of it, we had talked about speech technology, ASRs, and some of the speech emotion recognition. So again, please let's play the video.
Opened up a bank account. It was a while ago. And there was a lot of paperwork. You had to bring in a lot of forms of identification.
能不能妥善义务之处罚怎么做
Let me put to the point, okay, of the speech part. Okay.
Understanding what somebody wants through their voice can be very accurate, but it can also be very misleading.
Speech is one of our modalities. Language is one modality. Speech recognition has been around for a long time, but it really is capable of doing large-scale speech recognition, like spontaneous speech, only recently. Working on speech recognition and text-to-speech synthesis.
OK， 这个351就违反这个扣缴义务这个处罚，这个要给他很有处罚的感觉，就有点警告意味要有点严重那样子。
参阅所得税法第92、94之1条，违反扣缴义务之处罚。
这不错。
One of our research directions is actually make conversation on AI to understand human intent or the emotional state. Conventional machines they just know the word, they don't know the intent or the emotional state.
So, can a computer read emotion? Maybe it can. For example, if I'm asking you for a loan, can I have a loan? Can I have a loan? Can I have a loan? Those are the obvious extremes of asking for a loan.
Okay, when you're angrily asking for a loan, and when you're happily asking for a loan, it's completely different stuff. The way that the agent should respond is completely different.
And as a person to person, it depends on how I'm feeling that day, how you're feeling that day, and that can really change how I read what a person is saying to me.
If I just so happen to interact with somebody that knows me, I can connect from the trust perspective. Speech recognition is very specific. It means coming from acoustic to words. Okay, so what you need to do is have a database that has this parallel.
我们要再下两句开始稍微态度积极一点。
have a lot of that data, you can slowly start to understand how voices change when they're feeling different things.
机构存款及其他各种负债准备金调整及查核办法第357条。依据国际财务报告准则。
Once you collect enough hours, usually that's in hundreds of these or even thousands of hours, then you start to design an algorithm to say, okay, these are my sequence of inputs of acoustic sound.
有什么玉山可以为你服务的？玉山银行，您好。
These are my sequence of output of words that combines acoustic model, linguist model, the way we make it sound, the way we string together words. Now, once that system is learned, then we translate that into a sequence of words. Once you have that, you're done with speaking.
我的客服代号是523。玉山银行，您好，请问您贵姓？请问是李先生吗？
Speech is one of the most natural communication medium, so we feel comfortable talking and then requesting information and even just chatting. And I think that builds up a trust. I think really having a conversational AI or speech recognition, this kind of technology, bridge that gap. So having the trust and the very good user experiences brings the entire industry forward.
Yeah, as you can see, there are two kinds of technology we're talking about with speech, right? Speech recognition, and on top of that, understanding human emotion from the speech sound. So we'll talk about that, today. So let me move on to the next slide. All right, so again, speech recognition now, as I say, large-scale speech recognition systems has already been deployed across the world. We see a predicted market in 2030 into 15.87 billion across the board. The largest market now is in North America. Of course, technology happens there first. The market starts to grow. The most significant growing is in the Asia Pacific market. That's where language is very interesting. It has this sort of a cultural language barrier, starts in the Western culture, then slowly going into Asia Pacific, where again, when the data collects, when the technology evolves, then speech technology services start to flow. Okay, so you'll see a lot of key industry players in speech recognition development. All the well-known names you know, Apple, Amazon, Google, Microsoft, Nuance, and so on. Nuance has been recently bought by Microsoft. So a lot of this speech technology company has been merged into even a larger and larger scope. But not just that, right? On top of that, we add a touch of human, right? So, speech recognition, okay? Then speech recognition, taking the sound to words, now taking the sound to words and the emotion of that person. So, by analyzing speech, there are lots of different healthcare or different application has been emerged to actually recognize humans' emotion to do stuff. Like, for example, in healthcare, you have robots to do accompany robots, so it knows the emotions of the person or elderly, so they can better interact with the elderly. Automotive industry is very interesting. It's investing quite a bit in driver monitoring systems. So I always say, vehicle is a very nice, environment where a lot of the previous technology has been centered around what's external to this vehicle. It's gonna drive itself. So it's gonna have to sense outside. As that starts to get mature, people start to look inside of that vehicle. Okay, looking at what the driver is doing, what the emotions of the driver, what the emotions of the passengers, how do they interact. So we can design a better, say, entertainment system. Or we can design a better, say, driver monitoring and also making sure they are not fatigued and so on. Okay, so human resources interviews, remote interviews and so on. So for personal assistant, people already know in your home series, all these things, they don't just look at your words to do actions. They can also analyze some of your voice tone and then try to react appropriately. So there are a wealth of studies that actually starts to, application that start to come from, pure speech recognition now. Add a touch of emotion to it, and then you have a new set of applications you can think about across industry. So again, back to this timeline. Okay, so we've already seen this thing happening. From my personal journeys, where I have come from and how I see the field has emerged. Okay, and some of the recent issues that as a field where we're heading, and some key technologies that need to be developed. So in this kind of research timelines, I want to talk about affective computing from speech, from science, computation to nowadays human-centered application. In each one of this, I'll talk about basically that's my personal academic journey. This is a book chapter I published when I'm just about to graduate my PhD degree. Okay, back in 2014. I graduated in 2012. So once the paper get reviews and so on, it get published in 2013. Okay, so there was a handbook, the Oxford Handbook on Affective Computing. In one of the section, it's called Speech Affective Computing. I'm the first author on that. In that particular chapter, the things that we're talking about in that chapter back in 2012, we're talking about emotional speech production. We know from science, we know how human produces speech. We move our articulator in a particular way to produce ah. Okay. Now, if you're angry or you're very excited when you're producing that ah, okay, your articulator moves in a different direction. That creates a different acoustic sound. That creation of acoustic sound, when you record using microphones, then you'll be able to analyze that particular emotional properties. Okay, back then, that's what we're talking about. We're talking about science. We're talking about how we understand how we human produces speech, how we human perceive speech, at the same time that reflects in acoustic sound, how we do signal processing techniques to do, extract certain properties. And at that point in time, we also talked a little bit about speech-based emotion recognition. Back then it was all about support vector machine. That's like the hottest recognition systems. Nowadays, nobody uses SVM anymore, right? But still, at that time, it was a very, advanced sort of mathematical models to do recognition. Now, time rolls. Okay, as we know, in about 2013, 14-ish or so, at the same time, deep learning started to emerge. Okay, people start to realize deep learning is a subset of machine learning techniques that works well. Okay, now then the rest of the years, researchers in speech emotion recognition has started to adapt the techniques of deep learning, where there are a lot more data, a lot more unified framework of dealing with different issues of affective computing. So in 2021, then I wrote another paper. Okay, it's in IEEE Signal Processing magazine. Okay, invited by this set of editors. If look at the name here, Rosalind Picard. Okay, she's the one that coins the term of affective computing back in 1995. Okay, so she was also the editor of this issue. At that point now, we again write like a paper or like a chapter on deep representation learning for affective speech signal analysis and processing. We're talking about issues of speech-based affective recognition. Okay, in three particular concepts. One is acquisition. Okay, meaning the approach that we need to do, not be able to recognize not just in lab space. You need to be able to do it across different acquisition settings. Here I'm recording my microphones like this way. Okay, if I talk on the phone, okay, that acquisitional devices are different. Okay, how we can design deep learning techniques or the signal processing techniques that be able to handle the robustness across different acquisitional contexts with various kind of noisy background, such that speech emotion recognition system can still work. Okay, so and second is application. It needs to be generalizable across different applications. Frustrated customer call center state, okay, may not be the same as a frustrated student getting a bad grade. Okay, so even the word of frustration, okay, may not mean the same thing across different contexts. Okay, so when we design emotion recognition system by building it as a machine learning system, giving a label, doing a signal as an input, how do we make sure those labels are generalizable across contexts? Okay, not just the signal conditional context. The labels need to be generalized across context. If you're in a psychiatric clinical health conditions, an unhappy patient is not the same as an unhappy customer call center in a banking customer call center. So how do we make sure those naming the same labels, but inherently they're different? How do I do some kind of transfer learning at that time? Okay, at 2021, there was slightly to touch upon the aspect of users. Okay, when we try to do large-scale deployment of affective speech technology, we need to worry about the model size. Okay, for example, we need to worry about whether people feel like their privacy being intruded. Okay, they want to feel like maybe they don't want to share their data. How we develop those algorithms. It was a smaller section compared to these two back in 2021. We start to touch upon coming from developer now into a user perspective. Okay. Now continuing, this things rolls really fast. Nowadays people all talk about trustworthy AI. So in 2023, we had another paper, again, a survey paper that published in Proceedings of IEEE. Again, this is one of the most influential journals across entire IEEE. Again, the topics: engineering view on emotion and speech for analysis, predictive model, basically the past 2 papers that we talk about. Now, large sections on responsible human-centered application. So the paradigm has shifted. It has shifted from, as a developer, we want our models to be robust. We want our models to be accurate. Now, switch it to, now we want our model to be trusted. Okay, what do we mean by trusted? No, the trusted meaning is trusted by the user. Okay, it's not trusted by the developer, because developer, we know, we trust our models. We think our model works well. We think our model generalizable. But if the user don't trust you, they're not going to use it. If they're not going to use it, the thing cannot scale. Okay, the deployment issue become an issue. So the trustworthy issues start to arise. So we want to make sure all these technologies are accessible to all, maximize their benefit, leading to responsible human-centered computational application that's coming from the user perspective. Okay, so we'll talk a little bit more about this next few slides. Not all of them are in very hardcore academic research sort of publication. We were also published a work in Scientific America, which is very popular science magazines. Okay, at that point in time, we're doing this kind of a paper writing because there was another journalist write a paper that criticized affective computing. Okay, basically it says it intrudes the privacy. Okay. Is recording something that people aren't willing to share. Also, at the same time, from a lot of psychologists think affective computing is not really computing the emotion. Okay, you're computing a expression, okay, of what the person trying to express. So they're trying to disentangle, like, you're not really computing emotion, you're computing what's being observed. Okay, so there are psychologists also criticizing this. So there are lots of multiple people are criticizing the entire field of affective computing. And then the editor comes to us and asks us to write something about it, and we of course write a little bit neutral article saying, okay, yes, of course I understand that as an AI we assess your emotion, maybe that can be intruding, okay, but I think as a whole community, as a whole society, we need to discuss about what can or cannot be computed. How do we compute it? What kind of strategies to compute it so that users can trust us that this technology works well. It benefits you, so you can accept it, and then we can move forward. So instead of taking the viewpoint of let's stop it, don't go further, we take a viewpoint and saying, okay, let's discuss. What's your worry? Okay, how we as developers can address those concerns and help you guys. So again. So the 3 issues in terms of these things, we now narrow down to 3 issues: safety, fairness, and privacy. Safety is key. Okay, deep learning, as everybody knows, it's based on backpropagation-based kind of learning. Okay, basically meaning the gradient-based learning. So if you can add certain perturbation to your input that's based on certain gradient, you basically destroy that deep learning technology. Okay, so it could be basically from non-functional to non-functional. And it can be worse, it can be misleadingly non-functional. Okay, meaning when I can have original speech motion recognition do good happy recognition, now you add some noise into your signals, now become chance level of recognizing happy. Or you can purposely add a particular gradient, it becomes happy to sad. Okay, so every time the signal comes in and add a bit of gradient, it becomes sad. Okay, it basically deters the entire decision process. So how do we ensure our model is safely against that kind of attack, right? So again, second, privacy. When I sign up for the service of speech recognition, I may not sign up for the service of emotion recognition. When I sign up for the service of emotion recognition, I may not sign up for the service of speech recognition. Okay, as a technology developer, how can we disentangle that? Can we actually make that control back into the users? Let them choose what they want to reveal and then perform the task. Okay, instead of us saying let's collect everything and then run a recognition model on everything. And also the fairness. Okay, a model is being recognized good. If we look at it across accuracy across different subpopulation, you see it performs differently. Okay, that means some populations get better performance, some populations don't get as good of a performance. So what that means, as your system starts to roll out to the society, there will be some part of the population that benefits because you have an accurate system for them. Some part of the population will not gain that benefit because they just don't work for them. Okay, so how we can ensure that fairness? And it's more complex than you think. What's the most fair system? I always ask, what's the most fair system? That everything random, right? Everybody performs equally bad. Okay, but that fair system is useless. Okay, if you have a useful system that has to be fair, these are two conflicting constraints. Okay, how can we make sure that thing can be developed as a technology solutions? I'll list out some, recent work that we do, not comprehensively as a field. We're still trying to figure this out. Okay, safety. Okay, the recent work we do is we try to vaccinate this SCR. So while we again develop, I'll go through this quickly, not into any details, because we know gradient distortion is the major attack that we can perform on any system of the deep learning. So what we can do is actually do a self-supervised kind of approach of that the model during the learning, okay, explore the possible distorted gradient space. Okay, once you explore the possible gradient space, you're immune to that. Okay, so it's like, doing vaccines, right? COVID, like we may not hit directly that particular virus, but we know the virus has this kind of shape. Okay, we insert something very similar into your body, and your body, as it faces similar but not exactly kind of distortions, you'll be able to defend that. So our approach basically designed this vaccination strategy that the system explore self-supervisedly in the gradient distortion space, and then we prove that it works. Under privacy, talk about that quickly. Okay, so as we know, speech, okay, in a feature space includes all kind of attributes: your age, your gender, your ID, your emotion, your content. So what we need to do, if we can align, meaning if first 5 nodes correspond to your ID, okay, next 5 nodes correspond to your emotion, the rest of nodes correspond to your content. Then if we want to do some privacy aware sort of services, we just need to mask out a certain nodes. Okay, so mask out the first 5 nodes, so your ID are not going to be revealed, but your main task of emotion recognition are still going to be held perfectly. So what we need to do is design a learning strategy. So, aligning different attributes across different nodes. Okay, so we call it attribute alignment strategy. Okay, so at learning, we align those attributes to the nodes. At testing, then we can mask out different nodes according to your criterions. Okay, you want to do emotional free, speaker identification. You want to do, or you want to do speaker identification free. Okay, emotion recognition by just masking out certain nodes, and you'll be able to do that. And you can leave the control to the user what they want to do or not. But as a developer, you design a controlling mechanism that actually be able to do that. Okay, moving on to fairness. Okay. In speech motion recognition, the fairness issue comes from 2 sides. Okay, across a lot of the community, the fairness issue usually comes about, a certain population works better than other certain population. But in the emotion recognition, because the ratings are given by human raters, okay, and their subjectivity and the individual assessments of that rating of emotion, we also see the biases arise from the raters. Okay, what that means, meaning, what we see that is if we look at several benchmark emotion recognition data sets, if you just build a system, emotion recognition system built upon that, okay, we assess its output, you see it correspond more toward we call a female perspective, meaning because we have more females in our raters versus male in our ratings. So the system, as it learns on those emotion recognition systems, it's going to output an emotion label that corresponds better, okay, more accurate, more concordance with the how female see things. Okay, so again, this is extra layers of biases that's involved in terms of emotion recognition system. So a system that's being rolled is keep outputting a emotion labels, but that emotion labels is not uniformly across 2 genders. We have these gender bias issues. So we can design algorithms that actually take care of that. Okay, by making sure from 2 gender different perspectives, their embeddings, their laws, okay, they need to be as close as possible so that they're basically gender invariant. Okay, so by taking a system learning approach, we can actually design a gender de-biased SCR system, and we show that it works. Another thing I want to say that to you is, things get very complicated. Okay, when we make sure the raters genders are balanced, if we look at the speaker subject's gender, okay, so raters are balanced. Okay, the subjects, we look at them and start to become biased. Okay, so again, so basically what that means is our system output a labels, okay, that's from the perspective of rating is fair, but from the perspective of the person that's speaking, okay, that's not fair. Okay, and these 2 things are competing. okay, are competing criteria. You want to make sure the speaker-wise, whether I'm a male or female, speaking that utterances, the emotion recognition doesn't discriminate me, but at the same time, I want to make sure that system output isn't just because it's corresponding to raters that's male or female. Okay, and these two criteria start to compete with each other. Okay, this dual constraint. So we have to design we call it a dual constraint learning mechanism, like to make sure as we make this thing a little fair, make that thing also a little fair, and then we have an alpha as a dynamic controlling parameter. As through the epochs of learning, we can dynamically adjust the loss between the two, eventually make sure these two-sided are both fair. Okay, again, these are extra layers of complexity. We talk about fairness. Fairness to what? To whom? And that considered as fairness. Okay, but I think we're just scratching the surface on what we mean by a fair SCR. But all these things are important in terms of designing a trustworthy AI system. Last thing I want to talk about is, through this process, we realize, there's a lack of a database issue. So we also crowd a bunch of podcast data in the Chinese. We have a bunch in English, very few in Chinese. So we also spend quite a bit of effort, releasing a large corpus, everything annotated, almost 200 hours of data, fully transcribed, fully emotion annotated, gender balanced, rater gender balanced, and all these things are, so database itself isn't the source of biasness. So I want to make sure all this data can be, sent to the community for better research and so on. So I want to sort of close it up. This is a very brief overview of how I think speech affective technology has emerged to this point and where the future is going, right? So we start from science, We know humans have emotion, That's psychology telling us, We know from speech science, we know how a human produces speech, These two start to merge. We have a cross-interdisciplinary research across scientific exploration. Now we understand speech acoustic change as a function of emotion. Now, once that's okay, signal processing technology comes in and say, we can treat this audio signal as signal, deriving properties that reflects emotion. Now, as you collect more of those things, that's becoming a data issue, and machine learning comes in. Now, deep learning comes in, so a large data, a large things, we have a reliable system that's generalizable across different conditions. That's from a developer perspective. Now we're moving into enhancing human lives. But to be able to enhance them, they need to accept us. So the trustworthy issue comes in. How do we design, a safety, fair, and also a private SCR system for the entire community or entire society that be able to trust the system and use it, so that provides a benefit for them. And I think there's a lot more things that needs to still happen. Thank you.
Thank you so much, Professor Lee. Any questions from the floor? Since we are running out of time, so I guess there's only one question can be asked. So, any questions? So, thank you.
Thank you.
So
Thank you.
For the second talk.